Chapter 19, Solving Formulas and Geometry. Okay. A literal equation is an equation with letters. The letters stand for numbers. Think of replacing the letters with some numbers of your choice, except for the letter that is the unknown that you want to solve for. Why are literal equations or literal formulas useful? Imagine the following. You want to solve x minus 3 over 2 plus 8, which is equal to 1. You subtract 8 from both sides. You multiply both sides by 2. You add 3 to both sides, and you do the addition, so x is negative 11. Now repeat the same steps for a similar equation. The numbers are different. X minus 4 over 3 plus 1 is equal to 7. You subtract 1 from both sides. You multiply both sides by 3. You multiply out. You add 4 to both sides. X is positive 22. And again, you have x minus 0.3 over 0.2 plus 0.8, which is equal to 0.4. Step 1, you subtract 0.8 from both sides. Step 2, you multiply by 0.2, carry out the multiplication, and add 0.3 to both sides, so x is 0.22. Now, every time we are performing the same steps. Now, let's develop a general formula for the identical, that is identical to the 3 examples that has letters instead of numbers. So x is the variable we are solving for. X minus a over b plus c is equal to d. Step number 1, subtract c from both sides. Step number 2, multiply by b and distribute. Step number 3, add a to both sides. And that's it. So x is b times the quantity d minus c plus a. Okay. Plus a, yeah. Let a be 3, b is 2, c is 8, and d is 1. Our answer is 2 times 1 minus 8 plus 3, 2 times negative 7, which is negative 14 plus 3, or negative 11, just like what we came out with before. Another example. A is 4, b is 3, c is 1, d is 7. X is 3 times 7 minus 1 plus 4, which is 18 plus 4, or 22. Now, wasn't that the number we had before? A is 0.3, b is 0.2, c is 0.8, and d is 0.4. 0.2 times 0.4 minus 0.8 plus 0.3 becomes negative 0.08 plus 0.3, or 0.22. The 3 results above corresponds to the results obtained in A, B, and C earlier. Evaluating an expression is usually easier than developing a formula. Did you notice that the steps in developing the formulas were identical to the steps in A, B, and C earlier? So when you are faced with developing a solution to a literal equation, write the original equation next to a similar equation with numbers of your choice. Any numbers, almost any numbers. 0 and 1, and maybe sometimes 2 are not good choices. Each step taken with the numbers corresponds to the step taken in your literal equation.